Perkin Elmer UV visible NIR spectrometer Lambda 900 model. This system is interfaced to a computer, and UV WinLab software is used to run the machine. The system is connected using the serial port on the PC. So the icon here, UV WinLab 5 is the icon for the software guide. So this is the user's guide to help the operator to understand the machine thoroughly, how to run the system and program it. The system can be used for measuring the spectral performance of various samples. Either both absorption or emission spectrum can be studied. And to actually run the system, Perkin Elmer UV WinLab, this icon should be clicked on. And Perkin Elmer login allows to log in as 4 different users: administrator, analyst, and developer, and Perkin Elmer service. So to demonstrate the system in working mode, I'm going to log in as Perkin Elmer service. There is no login password or anything. So on the screen there are methods, and once you click on the methods, we see various system folders, and the scan routines which are created previously on this machine are visible. Any user, before attempting to run the machine, should thoroughly study the user's manual and understand the performance of the machine, because this is a high performance machine, high accuracy system, and only trained personnel should operate this machine. By clicking on the instrument, we can see how the system is connected. The serial number of the machine is here, and it is connected to the COM1 port. So by clicking on the scan method, so I'm able to now open the system here. So here is the data collection screen. So in this screen, the starting wavelength, and from where you can start the scan, and the end wavelength values can be entered, and also the scan steps, in steps of nanometers we can enter. And the sample info can be entered depending, we can enter any, if the name of the sample is known, it can be entered. For example, I can enter it as sample 2, and then we can also enter the data. And once we enter the sample data, we can run a scan by clicking on the start button. Before I proceed with the the actual running a scan, I want to show certain important features available on this system. We are already familiar with the data collection screen and the sample screen, and there is a processing feature. This is the processing screen, and various process parameters can be entered, and also there is a result screen. So the results, once after a scan, the sample results will be available here. And there is another screen that is a reporting screen. In this screen, the system will show all the raw spectrum data as well as the other parameters of the instrument, such as what are the lamps used, and the changeover wavelengths, and the types of slits inside the machine, and what are the photomultiplier gain and photomultiplier to response seconds. There's a fraction of seconds, like 0.2 seconds. So these parameters have to be appropriately studied before proceeding with the actual operation of the system. And factory training is recommended to new users. So this is just the instrument screen, and it is only showing where it is connected on the COM port. And for any reason, if the COM port is to be switched, then we can change the COM port number here. And in this, also there are various set of users and groups can be created on this machine in order to help with the to keep information about various users, and their data can be stored in various folders. Just to demonstrate, I am reinitializing the computer. So this system runs with the Windows XP application software. This is the login screen. Before starting a scan, enter the sample data and then go to the data collection and enter the from and to scan wavelength range. So I'm just going to check this system for the total scan range one time. From the instrument is capable of going from 3000 to 200 nanometers. So I'm going to run this just to demonstrate the system scan range. So once we enter the start wavelength 3000 and wavelength 200 nanometers, and then it's going to be just a scanning of sample. So to start the action, we press start. So any samples inside the system should be removed. So right now the spectrometer is driving to the beginning wavelength, and the system reached the 3000 nanometers wavelength. And now it says if there are any samples inside the sample chamber, to remove it. I'm just verifying it. and then press OK. So there are various tiny buttons here for changing the full range of the scan and auto ranging the x-axis, which is the wavelength, and the auto range of y-axis, so that depending on the signal amplitude, the signal level, the y-axis will be adjusted. And then there is also a feature of vertical cursor mode. And the graph can be formatted at any point of time. So once the scan is complete to the end wavelength, the system will prompt to enter the sample, and also once after this graph is plotted, we can also label the peaks. And also the display split feature also is available on this system. This is just a simple scan method. Currently the system is performing auto zero feature. So the system now is prompting to enter the sample. I have a colored glass, a red color filter. I'm going to enter it just to simulate a sample. So right now the scanning is in progress, and you can see the detector signal with respect to the wavelength. So it is possible to scan both from lower wavelength range to higher, or higher to lower. The system has two lamps in it. One is a deuterium lamp, another one is a tungsten filament lamp. So the red color filter I have filters all the lower frequency. The absorption is higher. It starts from 550 nanometers. The absorption is very high. So it confirms the properties of the filter I have here. So it transmits all the higher wavelengths above 550 nanometers. So I'm going to run another sample here. So I'm just adding one more sample. And then also I want to change the data collection range. I want to enter 200 to 750. Oh, it didn't take the lower wavelength, so I'm going to enter 750 to 200, and we can resolve it in steps of 5 or 3 nanometers, and we can start our scan. The system will be included with a brief operation procedure of this machine. So these sample runs are for demonstration purpose of the functioning of the machine, and the features of the instrument are being tested. Placing a sample in a sample holder to it and running a scan from 750 nanometers to 200 nanometers. There is also a feature we can, at any point of time, display the transmission or the absorption of the radiations through the sample. So this shows the blue color sample as soap solution I have. So the blue color is because of its higher transmission in the blue color range, around 360 nanometers. I'm going to run another sample which is a green color solution. But before that, I want to add another sample here. After completing a number of sample scans, graphs of each sample can be displayed here by using the feature here. So this green sample shows a good amount of transmission at around 500 nanometers wavelength. So I'm switching between the scans. This is a different scan. So you can see the difference between the various scans. So this is for the green sample, and this is for the blue sample. You can see the peaks shifting to the left. So this is the blue sample. This is the green sample. But this is an additional feature in the software, in the data collection screen, we can see the various internal uh, parts and the beam path. So it shows two lamp sources and the lamp source changing mechanism, and then the method setting wavelengths here in this screen also can be changed if necessary. And here there are CBM values which can be changed, and also these are the two paths. One is the reference beam path, and in the sample compartment you put a reference sample here, and here we put the unknown sample. This is the actual sample. So right now there's nothing in the reference path, so I'm just referencing it to air. So the system requires a low pressure nitrogen purge in order to keep the chambers inside the system clean. It helps to keep the whole instrument perfectly well maintained for a long time. So detailed instrument details are in the manuals. The manuals will be given either on a DVD or the hard copies. So in order to turn off the system, just first log out or exit the. You can save a task or a method. It's all features available here, and then we can exit. So you can see the data collection here, and we can so I already have scan 2. I want to overwrite that and then proceed to exit.